Hi, welcome to my video on the equation of a hyperbola, transformational form with the center h, comma, k. The equation of a hyperbola in transformational form is x minus h all squared over a squared. Subtract y minus k all squared over b squared equals 1. That's the transformational form. And in this form, notice the x is positive and the negative is with the y. So let's look at it in this form. We have a center is h, comma k. The transverse axis, or the axis of intercept, is the horizontal axis, going horizontal is going sideways. The horizontal stretch is A, the vertical stretch is B, and the vertices are, the center is H and K, but because it has horizontal axis, it's the transverse axis, then we have the stretch of A is plus minus. So H plus minus A, comma K are the vertices. And the asymptotes are Y minus K equals plus or minus B over A and X minus H. And the graph, again, the center is H, comma K, so we can go, just pretend we have to the right and up. H is on the X and K is on the Y, so let's pretend that's the center. And the asymptotes, we'll take the center, which is H and K, and we will go, the slope is B over A, so we'll rise B, run A. We'll rise B and go this way. So the asymptotes are, we always draw, when we're going to graph, we always draw the asymptotes first. The asymptotes goes to, I call it the center. This is the center. And notice that it has, in this case, it has, like say, the horizontal axis is this way. So the vertices are here. So it's H, the x coordinate is H, and we add on the A and we subtract the A. So this is the vertices. So it leaves and goes towards the asymptotes like this, and it leaves and goes towards, because there's two sides to it, and that's the sketch of this hyperbola. So let's do an example based on that. Here we have this equation. Notice the x is positive and the negative is with the y. So the center is, the opposite of negative 1 is 1. The opposite of plus 2 is 2. The transverse axis, or the axis of intercept, is the x-axis, shouldn't say the x, is the horizontal, because it goes sideways. And the horizontal stretch, A squared is 4. So A is plus or minus 2. So the horizontal stretch is 2. When I say 2, it's understood to be 2 to the left and 2 to the right. The vertical stretch is the B, so B squared is 9. So B is plus or minus 3. So the vertical stretch is 3. And the vertices is the center, which is 1, comma 2. But the horizontal stretch, because the axis of intercept is the transverse axis, which is horizontal, we add the 2. So it's a 1 plus or minus 2. So we got 1 plus 2, comma 2, or we have 1 minus 2, comma 2. So we got 1 plus 2, that makes it 3, comma 2, and we have 1 minus 2, that's negative 1, comma 2. and be careful here. I said the center was 1, opposite of that, but this is a plus, so this is a -2. The opposite of a +2 is a -2, so that's a -2, -2, -2. I almost made that mistake, forgot to say the center was the opposite of what's in the brackets, so the center is +1, -2, and that's the vertices. And the asymptote is y, and notice we can have y plus 2 plus or minus, b is 3, a is 2, and it's an x minus 1. Notice what's in these brackets, x minus 1, that's what's here, y plus 2, and that's what's here. This is what we call the point slope form of the asymptote. So we want a graph with the center of x is 1, y is -2, x is 1, y is -2. The center is right there. And so we have the asymptote passes through the center, so we'll rise 3 and run 2. So we'll go rise 3, 1, 2, 3, run 2. So that's 1 point. So we can also rise 3 and go left 2, right there. Or if we want, we can go down 3, 1, 2, 3, right 2. Or we can go down 3, 1, 2, 3, right 2. 1, 2, 3, right here. And so we draw the asymptotes are a broken line. Better be careful. The asymptote is not a solid line, it's broken. And the asymptote, so there's 2 of them. And notice this is y plus 2 equals 3 over 2x minus 1. And this one right here is y plus 2 negative 3 over 2x minus 1. And I don't need a bracket there, even though I just put that there, but that's just a 2. And again, notice the center, 1, -2, and the asymptote, this is a 1, so this is a -1. That's a -2, so that's a +2. So whatever is in these brackets here in the transformational form, that's what goes right here. That's a quick way of doing it. Okay, that's the hyperbola that's on the transverse axis horizontal. What about the hyperbola which has a transverse axis that's vertical? And this is, notice that the x is after the negative and the y is in front. So the y is positive and the x is negative. So this will have a vertical. This will be up and down. So the center is still h, comma k. The transverse axis, because the y is positive, the transverse axis is the vertical. The horizontal stretch is still a squared. Horizontal stretch is a. The vertical stretch is the b squared, and take the square root, so is b. And the vertices, again, the center is h, comma k, but because the stretch is vertical, up and down, we add the plus and minus b to the y coordinate of the center. And the asymptotes are the same, y minus k plus minus b over a with an x minus h. That's the asymptotes. And the graph, the asymptotes, again, I'm just plotting it, that the center is h, comma k, so let's just pretend it's in the first quadrant. The center, h is x, let's go to the right, up, so let's pretend that's the center. And if that's the center, then the rise is b, and the run is x. The rise is b, and the run is, so this is right, this is left, or we can go down that many units. So if I went b units up, I go b units down to the right, B units down to the left. So there's the asymptotes right there. Oh, it's going through there, getting a little bit. So the asymptotes are broken lines going through the point. So this point is H comma K, but this time the stretch is B and is on the horizontal, so it's B units up. So notice we form a little box, rectangular box here, like that. And it's the corner of the box that the asymptotes are going through. And B units is right here. There's one vertex, there's the other vertex, and it's moving this way because the axes of the asymptotes are on the vertical. Notice if it was X was here and the Y was here, then the vertices would be here and here. Let's do an example. Again, notice that the Y is plus and the X is negative. So we have a vertical, the hyperbola is up and down. The center opposite of plus 3 is a minus 3. The opposite of a plus 1 is a minus 1. The transverse axis, because the Y is positive, is the vertical. The horizontal stretch, horizontal is with the X, so A squared is with the X, so A squared is 25. So A is plus minus 5, so the horizontal stretch is 5. The vertical stretch is B, so B squared is 16. So B is plus minus 4, so the vertical stretch is 4. And the vertex is the center, so it's a negative 3, comma, negative 1. But the stretch is 4 on the vertical, so that's with the Y, so it's a plus minus 4. And is with the Y, is up and down. So we have negative 3, and we have negative 1 plus 4. And the other one is a negative 3. The X is the same. And we have negative 1 minus 4. So we got negative 3 and 3. Or we have negative 3, negative 5. So what we'll do, we'll plot the center first, which is negative 3, negative 1, negative 3. X is negative 3. 1, 2, 3, negative 1. There's the center. That means that the asymptote, whoop, I forgot to do the asymptotes. So we have X plus 3. Oh, we do the Y first. Y plus 1, because the point Y plus 1. And it's B over A, so it's plus minus 4 over 5. And the X is X plus 3. Point slope form. So we have Y plus 1. And we have an X plus 3, and it's the B, which is 4 over the A, which is 5. There's the asymptotes, so we'll plot the center, which we already did. And the asymptotes are from the center, because the point is negative 3, negative 1, because the opposite of these. So we'll rise 4 and run 5. Rise 4, 1, 2, 3, 4, and go right 5, right there. And we'll go left 5, right there. And now we'll go down 4 from the center. So we go 1, 2, 3, 4, right 5, down 4, left 5. This is the corner of what they call the rectangular box. And the corners have the asymptotes passing through them, like that right there. So the asymptotes will go through the center to the corners of the box, because the asymptotes are slope of up 5, right, up 4, right 5, up 4, left 5. So the asymptotes go through the corners of the box. And There's the center, and the center is -3, -1. And the vertices are on the vertical, so x is -3, y is 3. So 1, 2, 3. So it's sloping going this way because the transverse axis is vertical. And this one is x is -3, y is -5. -3, -5 is right here. Now this one, notice I went -3, and I didn't go 3. This one should be right here. My mistake, I didn't go up far enough. So there it is right there. Apologize for that. This one should be -3, 3. And this one right here is -3, -5. So it goes out this way. And there it is. Sorry about that, I didn't go high enough on the x is -3, and sorry, x is -3, 3. There it is right there, not there. Went out like that. So notice that this one is axis of what we call the axis of intercept is vertical because the y is positive and the x is negative. Okay, let's do a couple of more just for a bit of practice so we make sure we know what we're doing. Graph. So I have this equation. Notice the x is positive and the y is negative. So the center, the opposite of -2 is 2. Notice there's no value for the y, so it's 0. This is the transformational form with the center. A squared is 4. So a is plus or minus 2. So the horizontal stretch is 2. So it's 2 to the right, 2 to the left. And this is understood to be a 1. So b squared is 1. So b is plus or minus 1. So the vertical stretch is 1. And the vertices are the center of 2, 0. But because the x is positive, it has plus minus the 2. It's added on because the axis of intercept is the horizontal axis. And the asymptotes are y minus 0, and it's plus or minus b, which is 1 over 2, and it's an x minus 2. So notice this is a 0, so we got a 0. This is a -2. And so if we want, because this one works out perfect, we can go y minus 0 equals a half, and or we can go y minus 0 equals negative a half of x minus 2. So this one works out to be, if we want to change it, notice we can multiply the half by the x and the -2. So it's a negative a half x plus 1. So the asymptotes, you can leave it like this, or you can multiply it by the b over a, which is the slope, and make it just, this is slope y-intercept form. Now let's plot. The center is 2, 0, so there's 2, 0 right there. And, I didn't do the vertices. The vertices are 2 plus 2, 0, or 2 minus 2, 0. So it's 4, 0, or 0, 0. So the center is 2, 0. The vertices are 4, 0, because you go 2 to the right and 2 to the left. These are the vertices. And the asymptote, we can go from the center, we will rise 1 and run 2. We will rise 1 and go left 2. We will go down 1, right 2, down 1, left 2. So this is the rectangular box, and the asymptotes will go to the corners of that box. So one asymptote is if we want, we can go from here. X is negative, y equals half x minus 1. The y-intercept is negative 1. We'll go up 1, right 2. The y-intercept is negative 1. We'll go up 1. Y-intercept is negative 1, up 1, right 2. Up 1, right 2. Or we can go from here. The center is 0, 2. Sorry, the center is 2, 0. I got to do the x and then the y. The center is 2, 0. And we will go up 1, right 2. So again, you can plot the asymptote from here, or you can do them individually. And this one, the y-intercept is 1, which is right here. And the slope is down 1, right 2. Down 1, right 2. Down 1, right 2. Again, I did the 4 corners and I drew the asymptotes through the corners of the rectangle. And this one is y equals a half x minus 1. And this one is y equals negative a half x plus 1. Notice this is a positive slope going up to the right. This is a negative slope going down to the right or going up to the left. And the vertices are 4, 0, so it's horizontal, so it goes this way. And the other vertex is 0, 0, so it's going this way. So notice it's the axis of intercepts is horizontal. And we have another one to do. This time we have, again, the transformational form. And notice that the y is positive and the x is negative. So this means we have a center. X is negative 2, so that's a 2. Y is plus 1, so that's a minus 1. And the a is with the x, so a squared is 25. So a is plus minus 5, so the horizontal stretch is 5. And the b is with the y, so b squared is 9. So b is plus minus 3, so the vertical stretch is 3. So when we say the horizontal stretch is 5 right, 5 left. When the vertical stretch is 3, we go 3 up, 3 down from the center. The vertices are the center, coordinates of the center, which is 2, negative 1. But this is the axis of intercept is vertical, so we'll add the 3 to the y. So it's a plus minus 3. So that's 2, and negative 1 plus 3 is 2, and the other one is 2. Negative 1 minus 3 is negative 4. And the asymptotes is y plus 1 plus or minus b, which is b is 3, a is 5, and it's an x minus 2. So notice this is the point slope form. This is y plus 1, perfect. This is x minus 2, perfect. Notice that the center from here is 2, negative 1, right? Now we'll plot the center of 2. X is 2, y is negative 1, which is right there. We have the vertices of 2, 2. X is 2, y is 2, right here. X is 2, y is negative 4. X is 2, y is negative 4 here. Now let's do the asymptotes from, we could multiply this out, but 3/5 of 2 will give us fractions to do it, so I'm going to plot the asymptotes from here. But before I do, from the center I will go up 3 right 5, 1, 2, 3, 4, 5. I will go up 3 left 5 right here. I will go down 3 from the center and go right 5. I go down from the center 3. Did I go up 3 here? Yes, it's down 3, so that's not supposed to be right there. That's not supposed to be there. Just take that away, because visually that'll mix me up. Not only you, but it'll mix me up. So I'll take it away so it won't be there. Sorry for that. Didn't mean to put that dot right there, because you go up 3, 1, 2, 3, right 5, and you go down 3, right 5, down 3, left 5, and you have the rectangular box, which is right there. There's the rectangular box. And the asymptotes goes to the corner, to the center, to the corners of the box like that. There's an asymptote. And again, when you graph a hyperbola, I always draw the asymptotes first. That makes it really good. And this one right here is the negative slope. So this is y plus 1 equals negative 3 over 5 x minus 2. And this one right here is y plus 1 is positive 3 over 5x minus 2. And you can let you see that. And we have the vertices of 2, 2. X is 2 right here. Y is 2. There's one vertex. And the other vertex is 2, negative 4. X is 2. Y is negative 4. And because the y is positive, then it moves out like this. And remember, as it goes out, it gets closer and closer to the asymptote, even though I'm not exactly drawn. So when I leave here, it goes out, further it goes out, closer it gets to the asymptote. And there's a picture like that. So there's the vertex, and this is this vertex. This is 2, 2, and this one is 2, negative 4. Again, this is the vertical axis, and that's the axis of intercept. We can't say it has the y-intercept is right here, and notice it has no x-intercepts. That's another set of problems to do. If we want to find the x and y-intercepts, we let x equals 0 and y equals 0. And the last one, there's one more to do. We have the equation of a hyperbola, y, because we have a plus x and a minus y. The center is the opposite. The center opposite of negative 3 is a 3. Opposite of plus 1 is a minus 1. The a values, a is with the x, so a squared is 9. So a is plus minus 3. So the horizontal stretch is 3. The b values, b squared equals 4. So b is plus minus 2. So the vertical stretch is 2. The horizontal stretch and the vertical stretch are positive, but the values are plus minus with the a and the b. The vertices are, the center is 3, negative 1, but because the horizontal axis is the axis of intercept, so we have plus minus 3. So we have 3 plus 3 minus 1, and we have 3 minus 3 minus 1. So that's a 6, negative 1, and this is a 0, negative 1, are the vertices. And we have the asymptote, we have a y plus 1, plus minus the b, which is 2, and the a, which is 3, so it's 2 over 3, and we have an x minus 3. So this is the asymptotes with both of them there, but if we do one of them, we got y plus 1 equals 2/3 x minus 3, and we have, if we work this one out, we will come to y plus 1 equals 2/3 times x. 2/3 times negative 3 is negative 2. And we keep working that out. We get y plus 1 is 2/3 2. I'm going to move that 1 over. Take it away from there. So y equals 2/3 x minus 3. And the other one is y plus 1 is negative 2/3 x minus 3. So this is the positive slope, this is the negative slope, and we continue to work this one out. We get y plus 1, negative 2/3 times x. Negative 2/3 times negative 3 is a positive 2. and y equals negative 2/3 x plus 2 minus 1, y equals negative 2/3 x plus 1. Okay, that's the two asymptotes. One is positive, one is negative. So we'll graph now indicating the center is 3, negative 1. The center is x is 3, y is negative 1 right there. The vertices are 6, negative 1, x is 6, negative 1, and the other vertices 0, negative 1, x is 0, negative 1. So this is the center. Now we'll plot the asymptotes. We can do it from here or we can do it individually, your choice. It makes no difference. If you do it from here, we plot it from the center. We go up 2, right 3, etc. So the slope is 2/3. So we'll go up 2, right 3. One is there. Up 2, left 3. The other one is there. We go down 2 from the center, right 3. We go down from the center, left 3. Down 2, left 3. So these are the corners of the box. The asymptotes are going to pass through the center, passing through the corners. There it is there. Make sure you can see it. And the other asymptote goes through the center, to the corners of the box. And again, this asymptote here is a negative slope, so y equals negative 2/3 x plus 1. And this one is y equals 2/3 x, 2/3 x, let's see, minus 3. Or we could write like this right here. We could have had this one, y plus 1 is negative 2/3 x minus 3. You could have wrote it like that. So either way you can write the asymptote in the point slope form or the slope y-intercept form. It's up to you. So there's the two, and the vertices are here, right here. And because the x is positive, y is negative, we have a horizontal transverse axis. So the hyperbola moves like this and like this, because the transverse axis is a horizontal axis. So you move from your vertices towards the asymptotes. So these are your vertices. So hopefully that helps you understand how to graph hyperbola into transformational form. And if you like my video, click the like button. If you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.